Well, groovy morning to you. We're going to look today at a new concept in which we are going to use what we call standard or z-scores to help us get a single digit positive or negative score that is going to help us determine where in relationship to other observations a specific value is. Is it above average, below average? And then in the future here, we are going to help um, use that z-score number to help us with percentiles. So a z-score is just as I said, a positive, negative, usually a number between -3 and +3 that helps me determine where a specific observation is in relationship to the others within that data set. A z-score of 0, that means it's not above, not below, but 0, right kind of in the center. That would be an average observation. So that would calculate or correspond to the mean of a data set, the average. So if I want to find the z-score, I have a very easy, straightforward formula that I'm going to use. I am going to take the observation value. Okay, we'll discuss this in the first example here in just a second. I'm going to take the observation. From it, I will subtract the mean. So take that difference first, and then divide it by the standard deviation of the data set. The nice thing is I am going to give you all these values here. You don't have to calculate standard deviation by hand. I guess you may have to calculate the mean in some examples, but most of the time it is just given to you. So here's what it looks like symbolically. We have z, which is your z-score, is equal to x. Now x is just my observation value. Take away x bar. X bar, that is the abbreviation for the mean of a data set. And then divided by this little lowercase Greek symbol here is a lowercase sigma, and that is used to identify or abbreviate the standard deviation. So looks, a little, it looks like a foreign language, which, sometimes can happen in math. But let's just put it into practice here, and I think you'll have a great time with finding z-scores. So we're going to look at the heights of students. So if you think about heights of students, you have some people who might be a little short, but you got a lot of people who are, kind of average height. Then you might have some outliers, some tall players in the class who might be completely tall, but you got most people kind of right around the mean. So we've got a class of students here, and we are going to analyze their heights in inches. The mean is 67 inches. So I'm going to say x bar is 67. And a standard deviation, sigma, of 4.29 inches. I want to look at Misty here. She is 60 inches tall. We want to figure out what is her z-score. So if she had a z-score of 0, she would be average. She would be 67 inches tall. So here are my observations, and here are my z-scores. So since Misty is 60 inches tall, she's somewhere right down here between this 58 and 62. So my z-score of 0, I said, was mean, average, 67 inches. If she is 1 standard deviation above the mean, she would be 67 plus 4.29 inches, 71.29. If she is 2 standard deviations above the mean, she would be 67 plus 4.29 plus another 4.29. So each z-score numerical value either increases by 4.29 inches or decreases by 4.29 inches. So since she is at 60 inches tall, she's going to have a z-score somewhere between -1 and -2. She's between 1 and 2 standard deviations below the mean. All right, so let's find Misty's z-score. It's equal to the observation minus the mean over standard deviation. So in Misty's case, her z-score is the observation 60 minus the mean, which is 67, divided by the standard deviation of 4.29. All right, so I'm going to take 60 minus 67, which is -7, divided by 4.29. I'm going to get my fancy calculator here and crunch it. All right, maybe you've crunched it. If not, ready or not, here it comes. -7 divided by 4.29. We have got about -1.63. That's kind of what we said between -1 and -2 would be that 60 inches, so -1.63. Excellent. So Bruce is 77 inches tall. He's way up here. So he is above average, so his z-score would be a positive number. So Bruce's observation is 77. Mean, we're still with 67, and standard deviation is 4.29. So Bruce's z-score is equal to his observation, 77, minus the mean of 67, divided by a standard deviation of 4.29. All right, so 77 minus 67, of course, is 10, divided by 4.29. Let's crunch it and then munch it. So 2.33. Groovy. Let's take a look here at working forward and backwards with finding z-scores. Again, you are going to have usually a number between -3 and +3 for your z-score. So in this example, we have a math test. Mean score average is 80. So x bar is 80. And then standard deviation is 6. So my sigma is 6. I want to find the z-score corresponding to a student who earns a 92, a 71, and then an 80. So z-score will be my observation 92 minus mean 80 divided by standard deviation of 6. 92 minus 80 is 12. 12 divided by 6. This would be a z-score of 2. So this student would be 2 standard deviations above the mean. He would be above average because 92 is greater than the average of 80. So notice here it is a +2. If we had a student who scored below average, like a 71 is below 80, this z-score would be a negative number. So this z-score will be the observation 71 minus the mean 80 divided by standard deviation of 6. 71 minus 80 is -9. -9 over 6 gets me -1.5. So this student would be 1.5 standard deviations below the mean. Well, 80 is average. So if you're average, again, that corresponds to a z-score of 0. So we should get 0 here. Let's confirm that. So the z-score here is equal to my observation 80 minus the mean, which is also 80, divided by my standard deviation of 6. Well, 80 minus 80 is 0. 0 divided by 6 is 0. So there we have it. Again, a z-score of 0 would be average. You're just average. You're a 0. You're not special either way. I take that with a little sarcasm. I hope you can hear that. Okay, last set here of examples. We are going to work backwards. So I want you to tell me if a student has a z-score of -1, if they are 1 standard deviation below the mean, what was their score on this math test? So if we write out our formula, z-score is equal to observation minus mean divided by standard deviation. I'm using the same information that I had above here. So now I'm going to plug in -1 for z, and I'm trying to find what was the raw score. So I'm going to have z -1 equals observation minus mean, which is 80, divided by standard deviation of 6. So first thing I'm going to do is get rid of the fraction bar with multiplying both sides by 6. 6 times -1, -6 will equal x minus 80. And then I'll add 80 to both sides. 80 minus 6, 74 would be that student's raw score. Again, if they have a negative z-score, that should make sense to you that, oh, it's a negative z-score, they are below average. All right. Here we have a z-score of positive 0.5. So z, 0.5 equals my observation, which I don't know, minus the mean of 80 divided by standard deviation of 6. Same process, we'll get rid of the fraction bar, multiplying both sides by 6. 6 times a half is 3, so I'll have 3 equals x minus 80. Adding 80 to both sides, 3 plus 80, 83 would be my observation. So 83 would be a positive z-score of 0.5. Okay, positive 2.5 z-score. So again, I'm 2.5 standard deviations above the mean, so that should be an above average score, so above 80. So I'll say z, 2.5, is equal to my observation minus mean of 80 divided by standard deviation of 6. Get rid of your fraction bar. Are we having fun yet? Undo dividing with multiplying both sides by 6. 6 times 2.5 would be 15. I'll go down here. Hopefully that shows up. 15 will equal x minus 80. Add 80 to both sides. 15 plus 80 is 95. So if you get a 95 on the test, you would be 2.5 standard deviations above the mean. If you think about it, with a standard deviation of 6, starting at 80, 1 standard deviation, 80 plus 6 would get you to 86, plus another 6 would get you to 92, plus half of 6, 3, 92 plus 3 gets you to 95. So some of that you might be able to do mentally, but especially with the nice whole numbers here, but there are going to be examples like we saw with the first two here where you're going to have to know the formula to get that rounded or approximate result. Enjoy, fly on, have a superb day.